Hello, everyone. We are happy to present our senior capstone project with BI Incorporated, which we have entitled BISON. BISON stands for BI Incorporated Stream Optimization Network and is an investigative look into complex event processing. Let's first take some time to meet the team. My name is Keefer, and I'm the project manager for this group.
Hi, I'm Qian.
Hi, I'm Erik. I'm one of the developers for this project.
Hi, I'm Tokumoto, and I'm getting a double degree in computer science and applied math. I'll be working for the DoD this summer, starting very soon, which I'm very excited about.
Hi, my name is Tianchen Wang. I'm one of the developers on this project team.
So a little background on BI Incorporated. The company was established in 1978. They are the United States' largest provider of GPS, alcohol, and radio frequency technologies and services. Some of their many products include GPS tracking for intensive offenders, court-admissible mobile alcohol monitoring devices, and equipment-free biometric voice verification. Their products currently assist more than 1,400 agencies across the United States.
Hi, I will introduce the general overview of the project. Currently, BI Incorporated processes big, massive data. Be more specific, it processes over 35 million GPS points and 8 million events in a day. Besides of receiving numerous datasets, they also need to do multiple processing steps, and it will cause massive CPU and I/O load. In order to conquer the difficulty, our goal is providing several CEP solutions based on a set of relevant use cases. After that, we will investigate, compare, and contrast these solutions to give BI the most objective suggestion to improve data center operations. For our approach, we will identify several technologies like Microsoft Trail, Apache Kafka, and Redis to create a solution framework in this project to achieve the requirement and satisfy the given use cases.
All right, so let's take a look at the three technologies that we spent most of our time investigating. Apache Kafka is an open source data streaming platform that has widespread industry usage. It is implemented primarily as a Java library with a significant amount of Scala as well. It has bindings for Python that are in progress, as well as many other languages, but those aren't as featureful as the Java library. It is highly scalable. That's its main selling point, is that it works as a distributed system that can handle just about as much as you throw at it. Microsoft Trill is an experimental, free, open source C#-based streaming data solution developed by Microsoft Research. It's implemented as a C# library, which means that it has highly flexible I/O and data handling options. Whatever you want to put in there, Trill can handle it. Another plus is that the fact that it runs on .NET Core means that we can work with it on both Linux and Windows environments. Redis is a cache layer. It provides functionalities of publisher subscriber models, some geospatial queries, and some basic stream operations. It keeps its data in memory so that we can access it quickly from multiple queries. This means that it has low latency and high performance for those repeated queries. It typically acts as a caching layer between a particular application and the backend database, though it does have some streaming capabilities.
At the end, we have total 4 solutions for the complex event processing. They are Microsoft Trail, Apache Kafka, Redis Stream, and integrated Trail Kafka solution. During the presentation to the stakeholder in BI, we demonstrate all 4 solutions and compared advantages and drawbacks of each technology. Overall, our projects are considered a success, since all 4 prototypes are properly developed and satisfy most use cases. We communicate which options are available at the moment for complex event processing and provided templates that BI could use as a starting point for the migration to a complex event processing system. Thank you.
Finally, over the course of our project here, we learned 3 very important lessons. The first of which is that communication is key. Team members should try to their fullest extent to keep each other informed of all the important decisions that they make, as well as of where they are along in their individual workflows. The responsibility of this falls on the shoulders of both the individuals and the teammates involved. They need to keep in touch with one another and both check in with and check in on each other. The second lesson that we learned is that time and labor should be managed to the fullest extent possible. And by this we mean that logical units of work should be completed and tracked with ample time to debug before major demos of deliverables. And this is just to ensure that there is enough of a time cushion there in case anything goes wrong, which it often does in this world. Our last point is that it's important to investigate multiple solutions before we commit to a single one of them. This is because committing early to a solution can lead to either improper or unoptimal work had we chose a different option. And it could necessitate redoing previous work due to a better solution being discovered later on when we've already, say, implemented a previous unoptimal solution. This has happened to us, and we learned our lesson. Now we're going to quickly demo one of our stream processing prototypes, mainly the Trill and Kafka solution. We have a Kafka broker running in the background, and here on the C# side, we have a Kafka consumer taking data from the topic and putting it into Microsoft Trill, our stream processor. This occurs in this file where we can see that we're querying for events and outputting the results to a console down here. We're going to see that we'll be testing whether or not two arbitrary IoT devices come within a 15 latitude-longitude radius of each other. So we're going to first simulate an event here. This is prior output. So this doesn't have any bearing on what's going to occur. But we can see that at first an event was registered here. And if we simulate another event coming in, we'll see that a second event will be detected and the device's names will be registered, as well as their total latitude-longitude difference, which is 0 because they're right on top of each other. And that's about it. And that's all. Thank you so much for watching our presentation. We've learned a lot and we've accomplished a lot in terms of our project and its deliverables. It was a wonderful class, and I wish you all the best. Thank you.